Hello, today we're going to look at graphical characteristics using Desmos.com. So we're going to take a look at minimum and maximums, increasing, decreasing, zeros, and continuity. You should already be fairly familiar with domain and range, so I'm just going to touch on that a little bit. But first off, we're going to start off with mins and maxes. So there are two kinds. There's an absolute minimum and maximum, and there is a relative, or what I'm going to use in class is local, absolute min or max. So when I talk about absolute, I mean the absolute highest point on the curve. So it could look something like this, and then that is your absolute highest point on the curve. It could also look something like this, where there are two maximums, one right here and one right here, but this is really your only your absolute max is right there. This is something called a local maximum. So a local maximum, which we talk about down here, occurs when there's more than one, whoops, wrong color, that's okay, more than one max, and your local is the lower of the two. So in this situation, your local is here and your absolute is up here. Okay, let's take a look at minimums then. So with the minimum, the same thing occurs. You can have absolute and you can have local. So in a curve, a basic quadratic curve, you have an absolute minimum. This is the absolute lowest point on your curve right there. But sometimes you'll have more than one minimum if we start to get to some funky looking graph, like this. Well, where is the absolute lowest point on the curve? That's right here. Okay, that is your, right here is your absolute min. And I'll just abbreviate it with ABS, abs min. Okay, and then all the other ones, we'll do in a different color, are your local min. So there's another local min there and another local min here. All right, so do you see the difference between absolute minimum? These are all minimums, but this is the absolute lowest point, and these are local low spots. Alrighty. So let's go ahead over to Desmos and actually look at some equations and write out what the minimum or maximum would look like. So we're going to start out with a basic x squared graph, so x squared. Okay, so as you can see, this curve has a minimum. And on Desmos, it's really nice. So x squared is the function we're working with. And on Desmos, you can click, it'll let you click on the mins and maxes, it'll tell you the exact point. So when I click on that minimum, I see 0, 0. And since there's no other minimums, 0, 0 has to be an absolute min at 0, 0. Now there are no other minimums or maximums on this graph. As you zoom out, you see there's no other turning points. So the only min or max in this situation is a minimum at 0, 0. So let's go ahead and take a look at a little more complicated of a curve. We're going to just walk through a couple. If I look at, let's just say x squared minus 2. All that happens in this situation now for x squared minus 2 is that that graph was shifted down, and we still have an absolute minimum, but as you can see, now it's at 0, negative 2. So let's look at x to the third. What would x to the third look like? You guys know by now the general shape of an x to the third graph, a cubic graph. So you should be able to predict what the min or max is. So x to the third. Okay, now it labels this point because this is where it crosses the x-axis, and we'll talk about what that means later. But is it a minimum or maximum? No, it's really not, because it's not changing from increasing to decreasing. All that happens here is it levels out and it continues on. So in an x to the third graph, there are no mins and maximums, so you can just write none. What if we had the absolute value of x minus 4? So in Desmos, you will see the absolute value bar, and then you can just type in x minus 4, and it'll go ahead and graph your curve. In this situation, you do see a low spot, so again, this is another absolute min. And it is located, we can click on it, and it will tell us it's located at 4, 0. Okay, let's take a look at 2 more curves. So we're going to look at next x to the third minus 2x. Okay, so this one looks a little different than the standard cubic function, which is great. Let's get a little variety. Whoops, just lost it. X to the third minus 2x. Okay, x to the third minus 2x is the curve here. So let's zoom in. As you can see, the graph comes up, hits a high point, goes down, hits a low point, and then goes back up. So we have 2 points here, and this is a maximum, this is a minimum. Now this is a local max. Because of the fact that it isn't the absolute highest point, but it is a high spot. So the local max in this situation would be negative 0.816, comma 1.089. Okay, and then we also have a local minimum down here. Which is 0.816, comma negative 1.089. So those are your 2 points. They're coordinates on the graph. It's pretty easy when they're labeled and we're just looking at it graphically. In the next couple days, we'll start to go into the calculator and actually find out how they figure out what this exact point is. All right. One more and then we're finished on mins and maxes. So let's take a look at a logarithmic curve. We will learn more about logarithms later. But in this situation, the graph approaches an asymptote at x equals 0, which means really this graph never touches the y-axis. It just gets closer and closer and closer and closer. So, and if you look at how it goes to the right, it just keeps getting higher and higher and higher and higher. So this is a situation, a logarithmic curve that has no mins or maxes. So again, your answer would just be none. All right, so that's a summary on mins and maxes. If you go ahead and watch the next video, you'll learn about intervals of increasing and decreasing.